What's up, little critters? Mr. T here for part 2 of our video lesson. So we're going to continue on with the isosceles trapezoid. So first off, we have one pair of non-congruent parallel sides, which are these two right here. And then, of course, the other pair of non-parallel sides are congruent. Now, if you look at the base angles right here, we actually know that since this is an isosceles trapezoid, just like in an isosceles triangle, those angles are also congruent. So, one other thing to note. The diagonals of an isosceles trapezoid, these beautiful lines I'm about to draw here, they are also congruent. Now, one thing I would like to point out, some of you might be asking, Mr. T, are those two top angles also congruent to each other? And the answer is yes. So we can go ahead and mark those. Now, I would want to give you a word of caution. Just because the diagonals themselves are congruent doesn't mean that they cut each other in half, nor do they cut those angles in the corner in any special way. Every isosceles trapezoid is different in that manner, but these things are always true about all isosceles trapezoids. So let's go ahead and move on to our first example. So we wish to find the value of our missing variables. We've got x, y, z, and w. So let's go ahead and solve for w since that's the first one. Easy to note that, hey, these two are congruent. Alright, so that means we can set them equal to each other. Now in solving this, we do want to try to move, again, the smaller variable over to the other side. And then lastly, we're going to want to move that 5. So then we will be left with w equals 11. Nice prime number. I didn't plan that, I promise. Now onto our angles. We can use our first base angle and say, hey, x equals e. Unfortunately, that doesn't help us. However, there is a reason why our first statement about the non-congruent sides are parallel. There's a reason why I mentioned that. Remember that when we were in our parallel lines unit, we said that parallel lines that were cut by a transversal created 3 different unique relationships. If you take a look right here, you will notice that the 70 and the x are both on the same side of the parallel line. That should be a double marking. I'll fix that. But that means that since they are on the same side and they're interior to the parallel lines, that means they're supplementary. So we can go ahead and say that x plus 70 equals 180. So then going from there, we're just going to solve it. So then you'll find that x equals 110. Now since we know that 70 and y are congruent, we also know that y is also 70. And then we go back and find that z is also 110 degrees. And there you have it. Now these are all involving the sides of your isosceles trapezoid as well as the angles. Now let's talk about what happens when you look at a problem with the diagonal. Again, we've got PR, which is this diagonal here. We've also got QS, which is this diagonal here. And if you remember from the box above, our diagonals are congruent. So we can say 17 minus 3x equals 5x plus 1. Now, I see the 3x, and there's a minus sign in front, so I know, hey, that's got to be my smaller x variable, x term. The 5 is positive, so that's going to be bigger. I want to move that 3 over by adding it. And now we're just right back to our beautiful algebra. (16) equals 8x. And so then divide by 8. Getting ahead of myself there. Don't do that. X equals 2. Alright, so again, if you need to at any point pause the video to copy this down, or if you need to replay anything, by all means, let your sub know. But otherwise, let's go ahead and move on. Now, we have a mid-segment theorem. It's similar to the mid-segment theorem we had in the triangle, and actually they're both essentially equivalent. The only difference is now with the trapezoid you have a top and you have a bottom. So now to get to the middle, we're going to talk about the average of the two. And here's what we mean by that. First off, we know that our mid-segment is parallel. What is it parallel to, you ask? It's parallel to your bases. So we can go ahead and put a parallel line arrow right there. And then we can go ahead and we can say that the length of the mid-segment is half the sum of the lengths of your bases. So take a look here. This is our beautiful formula. So that is my mid-segment. It is equal to 1/2 of base 1, which it doesn't matter if it's the top or bottom. I like to go top to bottom based on my picture. But 1/2 of the top base minus the bottom base. So I'm going to show you two different examples for this type of setup. One example will be a pretty straightforward one. The other one will be when you're given the mid-segment, how do you solve for a missing leg? So you'll have a nice variety to help you with your homework problems. So right here is our first one. So, mid-segment M is going to equal 1/2 base 1 plus base 2. I always write the formula out every time I do this. It helps me see, okay, what do I know? What am I missing? And then from there I just substitute in my values. So again, we are still missing M. But I do know my base 1 is 13. My base 2 is 19. So now we're just going to go through and solve it just like we normally would. You're going to work inside the parentheses first. So M equals 1/2 of 32. Half of 32 is 16. Alright. So now I still have a couple other things I can look at because, well, we're not quite done. We're almost there. I've got this little a, and I've got little b. Now, if you look back at the diagram above, you'll notice that because it is a mid-segment, the two left sides are congruent to each other, the two smaller pieces, as well as the two right pieces. Now, we cannot say that the left side equals the right side unless it's an isosceles trapezoid. But in my directions, I did not say that they were isosceles. So, the only markings I can make that this is congruent to this, and this is congruent to this. So, from one of our congruency properties, we know that A is congruent to 5, and B is congruent to 6. And there you have it for the first part of example A. Now, if you're feeling a little daring, go ahead and try example B on your own. See if you can come up with that. Otherwise, just hold on a second, and we'll go through example B together. Alright, so now the thing different here is that, oh, my mid-segment is down there. It's given to me. No problem. We can totally solve it still. So check this out again. We're going to go ahead and still write our formula out. But now I'm going to put the 10 where M is. For base 1, I'm going to put the top one, which is my x, and the bottom one is going to be my 7. Now, something you may or may not remember from your Algebra 1 class is when you have a fraction in front of a parentheses, you can multiply by the reciprocal so that you can get what's left inside of the parentheses as a single line equation. So in this case here, I can multiply this side by 2. And again, whatever you do to one side, you've got to do to the other. So now you'll have 2 times 10, which is 20. And that's going to equal x plus 7. The parentheses are gone, so now we can just go straight to solving it. And then we get x equals 13. Now, let's go ahead and solve for y and z. We know that these two sides are congruent to each other, as well as these two sides being congruent to each other. So solving for y, y plus 5 equals 2y minus 3. So my smaller y is the one on the left, so I'm going to subtract it over. 5 is equal to y minus 3. We're going to add that 3 over to both sides. And so we get y equals 8. Lastly, we need to solve for z. So z, we are going to say 9z minus 8 equals 3z minus 1. So I'm going to subtract my 3z, and I should get 6z minus 8 equals negative 1. No fear, we can add that 8 over to both sides. Since we have a minus 8, want to do the opposite. So then we get 6z equals 7. You're going to divide both sides. Oh, wait, Mr. T. 6 doesn't divide into 7. That's okay. You're allowed to have improper fractions. No fear. And there you have it. We have solved for x, y, and z for part B of example 4. So now at this point, you can go ahead and get started on your homework. These notes should be enough to get you through all the problems. There were actually originally a lot more problems on there. I took off a good number of questions, so you're welcome. Anyways, I hope you're all having a wonderful Friday, and I hope you guys have a great weekend. Be nice to my sub, please. If I hear of anything from you guys, I pity the fool. See ya.